Okay. Here we are. Take the quiz. Oh, need to share a screen. Okay, can you see? Okay, so this is the like the same as the exercise in the last quiz. So we just need to solve it. Yes. Okay, so here we need to set the boundaries. Also with z equals 0. So we have z from 0 to y minus 2 squared. So we can define d as xy such that absolute value of x plus absolute value of y is less equal to 1. Then the setup of the interval can be integral from 0 to 1/2 as the outer interval, and the inner interval from y equals 2x squared to y equals 1 minus x. Of z, which is y minus 2x squared dy dx. But do you mean split the intervals? Okay, so how do you split it? Okay. We will with the setup that I put, where the inner interval is dy and then dx. With the bounds, I already told you I get 17/80. Um, okay, so here we just need to find the bounds. So well, yeah. So the procedure is we need to set in the equation r equals 1 plus cosine of t. We set r, which is we already know it's equal to 1. We use substitution, and so there we can pass the 1 from the 1 plus cosine of t equals 1, so the 1 minus 1 cancels out, so we get cosine of 0. There we can get to the limits, and taking the r cosine, so we cancel the cosine, so we get t equals the angle. So that gives the bounds for minus pi over 2 and pi over 2 for t. And as Tiana said, the upper and lower bounds would be 1 and 1 plus cosine of t. Okay, so here we should work in terms of polar coordinates. So we said x equals r cosine theta and y equals r cosine theta. So we end up with z equals xy plus 10. Instead of that, we, by substitution, we end up with r squared cosine theta sine theta plus 10. And we replace the yes with r dr d theta. From 2 to 4, yeah, but then the bounds of the inner integral are with respect to r, so it's 2 to 4, and then we have the bounds with respect to d theta, so with respect to theta basically, which is from 0 to 2 pi. So the outer integral ends up canceling out for the term of r squared cosine theta sine theta, because we have from 0 to 2 pi, and that's going to give sine of theta equals 0. But then we need to solve for the integral of from 2 to 4. Which we only have, well, r squared, and the rest we treat the rest as constant. So when we integrate with respect to r, we treat r as a variable. So we end up with 120 pi for the final answer.